Hello. Swati madam.
Yeah,
Satyajit this side.
yeah. Good morning.
Good morning, madam. Last class was very much nice, madam. Very, very much nice. Very
Hello.
much.
Students liked it. I mean, they did they
Yes, madam.
enjoy?
Yes, madam. वो लोग सारे कुछ पूछ रहे थे तो वो
Uh,
बोलते कि सर दो सेशन में तो समझना उतना समझ ठीक से कैसे करेंगे बोले ठीक है हम लोग बाद में एक लॉन्ग सेशन करेंगे सिर्फ
uh,
मैडम का जिसमें कि पूरा चीज ग्रास रूट लेवल से लेकर के आगे तक जाएगा
हाँ. ठीक है, नो वरीज है ना. बच्चों के लिए तो एक्चुअली इट बिकम्स इजी because we
हाँ
have gone through the same journey. So making
हाँ
them understand is really a nice experience.
and due to your help in 2015 I had summarized my thesis.
Oh, great. So why your name is looking Arunima Asthana? I mean, there
Bec-
to
because I log in from Arunima's mobile. This
okay.
is
Yeah, yesterday I could make out, but I was little confused that because the name is different. But
yeah.
you have Arunima has also logged in from another account.
Yes, that is recording is going on for the YouTube session.
Okay, so you can change your name. That option is there, no?
Okay. Okay.
Yeah. So
Thank you,
today
madam.
I'll be discussing the second part. How do we develop the scale? Because as I said, it's not possible to take them through, but
Hmm.
I'll try to give them the overall overview that this is how things are done. If they have SPSS and if they have data, they
Hmm.
can do it on their own. So at least they will have fair idea that this is doable. That is more important.
Yes, that is the thing.
Yeah. So
So, madam, we
yeah.
are going to start at 9:55.
We
Is that
can do
okay?
that. Yeah, we can do that. If students are there, if everybody is there, we can start the session early.
Okay.
Yeah. By 5 minutes, we can have a quick recap from the last class.
Sure. Sure. Thank you.
Very good morning.
Good morning, ma'am.
Good morning. How are you?
I'm doing good, ma'am. How are you?
All good. Thank you. Any doubts from the last session?
No, ma'am.
Still excited for the session? No?
Yes, ma'am.
What are you doing?
Ma'am, I'm pursuing BBA.
Okay. At BIT only?
Yes, ma'am.
And what about the other people? I mean, other respondents? Is anyone pursuing PhD or they belong to MBA domain as well?
Ma'am, the person who are pursuing PhD, they are also there. And the person from MBA background, they are also there.
Should we start the session, Dr. Satyajit?
Yes, ma'am, we can start.
Yeah.
Apurva?
Good morning, everyone. On behalf of the IT Mishra fraternity, I would like to extend a warm and a hearty welcome to our workshop on short-term training program on research methodology basics organized by BIT Institute of Technology off campus Lalpur Ranchi. It's a great pleasure to have amidst us our special guest, Dr. Swati Dhir. Ma'am will be talking on the topic questionnaire design, measurement of construct design survey instrument. A special welcome to our director, Dr. Vandana Bhattacharjee ma'am, who has been kind enough to support our endeavor. A very warm welcome to our esteemed faculty members, other guests, and attendees present here. Our guest speaker, Dr. Swati Dhir, is specialized in organizational behavior and human resources. Ma'am is designated as an associate professor at International Management Institute, New Delhi. Ma'am, your presence with us is a refulgence and source of inspiration for the students present here. Now, I request ma'am to take forward the session.
Yeah. Thank you. Thank you, Apurva. Um, so I'll share the slides. So, any questions from the last class group? So, I hope it was clear what we discussed yesterday. So, there was a quick recap. We had, discussed all the steps when you are designing or developing a new scale for a given construct. Construct is nothing but an abstract idea.
Good
So,
morning, ma'am.
good
Uh,
morning.
Ma'am, can you repeat the concepts of first order construct, second order, and higher order constructs?
Okay. See, first order is something when you have reflective items measuring that construct. For example, we discuss materialism. So if there are 6 items, 5 items for which are all these statements are trying to evaluate or measure the materialism as a construct. When we have a multi-dimensional construct like personality, right? So if we talk about big 5 factors of personality: openness to experience, conscientiousness, neuroticism, emotional stability. So all those 5 factors will collectively make the second order construct, which is personality. So personality has 5 dimensions. So we call personality as a second order construct because it has dimensions, right? And they together make personality as a construct. Is that okay?
Yes, ma'am. And ma'am, what is a higher order construct?
Higher order construct is these constructs only. Higher order construct means second order construct, right? Now, if I haven't come across, though in research, the third order construct, but imagine this, the series will continue. If there are, micro dimensions of those second order constructs, then maybe there can be generated, we can also create third order construct. This is actually the higher order construct. The same second order constructs is at times called higher order construct.
Okay, ma'am. Ma'am, thank you so much, ma'am.
Okay, Rashika. So I was trying to actually go ahead. Any other question? Yeah. So tell me from your last session, can you see two tables on the screen? Which measurement is more reliable? So there are persons, Charlie and Harry, and they are repeated measurement. For example, if I am measuring their HR competence, right, on certain exam, the exam is a standard, right? And they are scoring like first time Charlie got 20, second time 19, third time 21, and similarly I did it multiple times, and he or Charlie is getting those kind of marks range. Harry is getting 15, 17, 16. The other person who was conducting the test, he designed or she designed it in such a way that Charlie, so first time he got 20, second time he got 10, third time 8, and similarly some other time he got 23. Harry got 2, 11, 4, 15. So whose test is better, mine or my friend's test?
Ma'am, first one.
First one, right? Why? Because the scores are pretty much consistent. Reliable, right? So whenever you are designing a new scale, it should give you the consistent results. Otherwise what will happen? Why do you think that the results are varying in the second box, in the second table? What would be the problem if I take a test which gives me these kind of scores?
Ma'am, maybe the respondent is not he's not able to get the answer.
Okay,
He's not able to understand the question.
Okay, but how come he could understand it the first time? He got 20. Maybe he was doing cheating or something. No? Online exams, you people understand it better. Right? What else could be the possibility?
Ma'am, it may also be the case that interviewer is not able to project the answers, project the questions well.
Yes, right. I was coming to that. Maybe there is some problem with the content. Maybe there is some problem with the design, right? Maybe the scale itself is not designed well. So it is so random that sometimes people get 10 or sometimes people get 20. Other things, I mean, you are correct in that way that the student or the respondent was not well aware. Maybe first time he was very enthusiastic, second time he was tired, he was sick, he was not in the right mental state. So you need to consider those aspects also when you are trying to develop a test. Why do I say that? Because all those things also create measurement error. Okay, measurement error which may come from the tiredness of the person, the unstable state of mind. So we don't have much control on that. What do we do? Whenever we want a respondent to fill our questionnaire or respond to a particular survey questionnaire, we try to make sure that the person is not in hurry. The person is in the right state of mind. The person is actually ready to read the questions and respond it. The moment people don't follow those guidelines, the data which you collect in hurry or sometimes maybe by forcefulness, that the quality of the data might not be good. So first thing, your skills should be well designed, because you have to be very sure about the quality of your scale itself. And then the second part, how would you assess it? That is also very, very important, because otherwise you will get inconsistent results, right? Moving ahead, as I said, consistency is reliability. Reliability test is once we get trust to measure the characteristic. If my test is not giving me the consistent results, how can I assure that we are measuring the right thing? So sometimes you may get consistent results, but you are actually not measuring the right content, right desirable construct. So you don't get influenced by the reliability scores. Number one, reliability is important. You should get every time with the same set of scale, you should get consistent results, number one. But at the same time, moving ahead, you also need to make sure that you are measuring the desirable construct, right, which is the validity. So you are measuring something which you intend to measure, right? It should not happen that I was measuring intelligence and somehow my questionnaires are designed to measure personality. Every time I'm getting the consistent score. So validity is also equally important, right? What are you exactly measuring? So the agreement between a test score or measure, that is quality, it is believed to be measured, right? So what I'm trying to measure, validity is something which is ensuring that yes, we are measuring intelligence and my all questions are designed in such a way that if a respondent is responding it correctly, you will be able to measure the characteristic. What is my desirable characteristic? Intelligence, right? A judgment or the estimate of how well a test measures what is purports to measure, evidence for the appropriateness of the inferences. So if I think that intelligent people are performing well in the organization, right? So if I'm measuring intelligence in the right way, then only I can conclude this remark saying that intelligent people are performing well with the help of all the analysis of the data. Validity refers to the test's accuracy. I had skipped this part. We had already discussed this in the last class. Okay, the types of reliability. Validation is a process of gathering and evaluating the evidences about the validity, right? I had discussed this. Even if a test is found valid for a particular purpose, it might not be valid for that purpose for all people. So that is why when you collect data, right, when you gather data, you need to make sure that your sample is representing the population. If not, then you cannot conclude your findings to the overall population. Face validity. How many have you heard about face validity? Any idea about that? What is face validity? Is it same as content validity or is it different? So the word itself is very clear. By the definition, face validity is something which actually in the technical terms, it's not a validity, right? But face is something, as I say, that once the moment you see the test, it looks like that it is actually a valid test, right? Lack of face validity could contribute to a lack of confidence in the perceived effectiveness of the test taker. If I, on the face, if I see the questions, the way it is designed, the way it is framed, the Google questionnaire, if you are creating, it should look like it is an, the appropriateness of the statement should look like. I'm not talking about the content part, right? So don't get confused with the face validity. It is important because overall the question or the survey which you are designing, it should look like it is you are trying to measure something which is really relevant and important. But at the same time, don't get confused with the content validity, because content validity is the systematic evaluation of the test by the expert, right? Whether it looks like or it does not look like, but the content, the kind of statement. So what happens, how do we do that content analysis? It involves identifying the content or the behavior domain to be sampled and then writing or selecting items that represent that domain. How do we do that? For example, the same example which we were taking yesterday, we want to develop a scale on gossip. I have defined gossip in certain way, right, following some school of thoughts from the help of literature. Now I am writing certain statements, right? Test items are not a good sample. Results of testing will be misleading. Test items, if you don't actually have right test items, so if sometimes what happens as an expert, when you read the definition and when you actually read the statements, there should be a coherence what you are trying to measure. Sometimes people get confused with the antecedents and the consequences. See, if you're defining a construct, that statement should try to measure that construct, not the factors which are leading to that construct. So be careful. I'll showcase you some examples. Okay. Moving ahead, I'm skipping some part. I will share the slides. You can share. You can read it later. But I wanted to give you some demonstration. So I'm skipping some part which you can understand by reading it. So coefficient of internal consistency will be large if a test has adequate content validity. Content validity means your content is very much well aligned with the definition of the construct. If it is a first order construct, right? Your reliability coefficient would be high because your statements are aligned with the definition. So it's a single order construct. People will be giving similar kind of rating. So you will be getting a consistent result for a given construct, right? Moving ahead, criterion validity. So remember, there are 3 C's of validity: content, construct, and criterion, right? Construct validity is the most important, which has both the components of content and criterion. So content is clear, right? How do we get the results for content validity? You can calculate Cohen's kappa value in SPSS, or there are content validity ratio also. So if there are 2 raters which are giving rating to your construct, you can see whether they are highly related or not, right? The judgment of how adequately a test score can be used to infer an individual's most probable standing on some measures of interest. What do you mean by that? Criterion. Did you hear this word predictors and criterion? X and Y, independent and dependent variable. So I am developing a concept at the same time. Why are we doing that? Because we want to infer something. How would you infer something? We will infer something when these construct, my construct, for example, gossip, it has some inferences on what? On some criteria. Because as you all understand that management does not want to do anything in isolation. Nothing is in isolation. Everything is contextual. So if I'm measuring some construct, how does it impact all outcomes of the organization? So try to connect your construct with a criterion. If your criterion is an established construct, we discussed that as a turnover intention last class, right? So if my gossip is highly related or it leads to turnover intention, then I can say, okay, if it is, because theory says that gossip, too much gossip in the organization will lead to turnover intention. Maybe people are talking too much about, rumors and all, so they are not very productive, and that will actually lead to turnover. So if I can conclude with my scale, which I had developed, that gossip is, causing turnover, that means my scale has criterion validity, right? How do we do that? I'll come to that, right? Moving ahead, criterion validity could be of 3 types: concurrent, predictive, and postdictive. It is little interesting. Criterion validity, now just listen carefully, right? It's something when you are saying that you are measuring both the constructs, predictors and criterion variables at the same time, right? Now, for example, when I ask you to fill up a survey, which I'm trying to develop a scale on gossip, I have also put some certain questions of criterion, which is turnover intention. 5 items. You will not be able to make out. I have included those 5 items across in my survey, which I'm conducting to develop a scale on gossip. That is called concurrent. At the same time, I have asked with the same respondents the gossip questions and the turnover intentions. Predictive. When I say that, I developed a scale on institutional effectiveness recently, that this paper got accepted in GBR. And what I did there, I was trying to develop a scale on institutional effectiveness, right? Like B schools, whether they are effective or not. And I was trying to see a predictive validity in terms of their NIRF ranking. So my criterion variable is NIRF ranking. Okay, so we got sample from different set of students from different colleges, and my criterion variable of the, at the end of the day, your institutional effectiveness is measured through some ranking. And in India, if you see, this National Institutional Framework of Ranking is a valid, what should I say, it's a reliable measure for effectiveness measure. So I was trying to see whether my scale has some kind of, correlation with the criterion variable, which is NIRF ranking. Postdictive validity. Now, for example, something has happened. A student has failed in an exam, right? And I was trying to develop a scale on stress, right? So what I'm trying to do, I'm trying to actually postdictive, which has already happened, right? And the student is already failed. A set of students, maybe example, out of 2,000 students, the set of 50 students have failed in a certain exam. So they have failed. I'm trying to actually now develop a scale on students' academic stress or academic anxiety. Now this has happened. I'm trying to actually explore and investigate what could have and happened, what is student anxiety, and my criterion variable is post-dictive, which has already happened. So I will take only students' score, right, as an anxiety score, what I'm trying to develop, which with a criteria, which is the exam result, which is passed or failed or mediocre. Okay, is that clear? Usually we follow, and the papers which I had shared, I had followed the concurrent method, right? So this is the pictorial presentation. This is my criterion behavior. If it is now, at the same time, I'm collecting the data for criterion and my construct variable, desirable construct, which I'm saying, which is nothing but the predictor for this particular exercise. If it is something which I'm trying to predict for future, right, this becomes my predictive criterion validity. And if I'm doing something which has already happened as a criterion, person has failed, now I'm developing a score or a scale on anxiety. So that means we can take my anxiety scale will be my desirable construct which I'm trying to measure, and post-dictive means the outcome was which is already has happened. As I said, construct reliability, construct validity, right? Construct validity is the most important validity. A construct is an abstract characteristic that cannot be observed directly, but must be inferred by observing its effects, such as intelligence, aptitude, self-esteem. That is the definition per se as construct, right? There's no single way to establish a test construct validity. And when a test has been found to measure the hypothetical trait it is intended to measure, the test is said to have a construct validity. As I said, it's a most important validity, because this is the same definition. If you follow of validity, the test is able to measure what it intends to measure. Okay, moving ahead. If your scale is valid, right, now think about this. What do you think? If there is an existing scale, but you are not convinced with this scale, and you say, no, this is not something with the way I define my construct. So your scale should have high correlation with the existing scale, or should have low correlation with the existing scale to have the construct validity? Tell me quick.
High correlation.
High correlation. So this is also one way of creating evidence for construct validity. It should have high correlation with any other distinct construct, existing construct, or should have low correlation? Any other distinct construct.
Ma'am, any other distinct construct, it should have low correlation.
Low correlation. And if it has low correlation, that means the construct validity is there. But the first one is called convergent validity, and the second one is called discriminant validity. It is very much discriminant than the other existing construct, but it is very much similar and aligned with the existing construct if it has a similar measure, right? How do we ensure that? We choose the right items, right? And this is the most basic form of validity, right? It overlaps, used to determine if a test has content and criterion validity, right? That's why I'm saying that the 3 C are important: content, criterion, and construct. Moving ahead, if it is measuring, if it has high correlation with the measures of the same trait, called convergent validity. If it is different than the other unrelated traits, it has discriminant validity. There is one more method which is called multi-trait, multi-method, MTMM. I'm sure you must have heard this word, right? What do you mean by multi-trait, multi-method is, even if you are measuring the same construct with 2 methods, the correlation between these 2 methods of the same construct should be high or should be low? Same construct measuring with the help of 2 methods.
Ma'am, it should be high.
It should be high to have convergent validity. Okay. Same method measuring 2 different constructs. The relationship should be high or low?
Ma'am, low.
Low, right? Now look at this table carefully. There are 2 constructs: attitude towards women, attitude towards men, and there are 2 methods: questionnaire and observation of behaviors. Questionnaire is a paper pencil test, and observation is an observation of behaviors, right? Now there are two methods, two constructs. If you see in the columns and in the rows, ATW, right, using a questionnaire method, and ATW using an observation method, right? The relationship is high or low? And can anyone tell me which column I am trying to refer? ATW with questionnaire method and ATW with observation method.
Ma'am, it is high.
High. What is the number? Yes, very good.
Ma'am, 0.9.
No, 0.9 is actually the reliability. These values
0.7.
because ATW and ATW. See, this is actually the diagonal, same value, ATW and ATW. This is 0.9. So all parenthesis values are the reliability. This is written here. Now ATW through questionnaire method and ATW with behavior method. I'm referring this 0.70. Can you see my cursor?
Yes, ma'am.
I don't have my pen today, so otherwise I could have actually drawn it here, right? ATW, same construct with two methods, questionnaire and the behavior method, 0.7. Now ATW and ATM and ATW. I'm referring this 0.30. Through observation, but two different constructs, ATW and ATM, 0.3, right? So it has low correlation because the constructs are different. Method might be similar. So is it clear? This method is called multi-trait, multi-method. Is it clear, class?
Yes, ma'am.
Right? So moving ahead, this is how you can actually do the convergent validity, discriminant validity, criterion validity, and content validity. All those four things can be done with the help of factor analysis. So moving ahead quickly to the main part of today's session is what is the need of doing factor analysis. Now imagine that I have defined gossip and I have developed, so I'll not take gossip now, I'll discuss my another construct which the paper I had shared is on employee loyalty, right? And employee loyalty, I was actually, to be honest, very passionate to develop that construct because I think this construct is a multi-dimensional construct. I thought with the help of literature, I just felt that when I was synthesizing the literature that employee loyalty should be a second order construct. However, till date, it was actually considered as the first order construct. And I define loyalty when people are retained in the organization and they feel respected, they feel they have a sense of respect in the organization, they trust the organization, and they want to continue in the organization. This is the way they actually try to showcase their loyalty behavior, right? This is the way I had defined loyalty. And I collected data, I developed certain number of items, and now I wanted to come up with the factors for loyalty. Right, so I had collected data. I'll show you that data. And now I am going to discuss with the help of data, how would you calculate content validity? How can you calculate criterion and construct validity, right? So both convergent and discriminant evidence can be obtained by factor analysis. I hope you know what is factor analysis. Anyone?
Ma'am, it is a reduction of factors.
Deduction of data points, not the factors. You will come up with factors. So it is a data reduction technique.
Yes,
Ma'am, it brings intercorrelated variables together under more general underlying variables.
Yes, correct. Very correct. Right. I can't see your names, but yeah, correct.
My name is Pooja Yadav.
Yeah, Pooja. So very well defined that it actually tries to come closer or make a basket of interrelated items or what you call variables, and there would be certain dimensions. Do you think factor analysis gives names also?
No, ma'am. We have to factor analysis का काम है मैम सारे जितने भी different variables हैं उनको एक generalize करना. Then we have to name all those factors.
Right. How do we name that?
Sorry, ma'am.
We get a self-actualization stage and we suddenly get to know the names. No?
No, ma'am.
How do we do that? Interestingly, no? So I agreed with your first understanding that yes, if there are, for example, 23 items, right? And now I'm running factor analysis. My data and my machine is helping me to come up with 4 factors, right? But it does not provide names. That is something has to be done by the researcher, because you are the person who knows it better. Machine can only give you that there could be 4 themes, there could be 4 dimensions which are emerging from your data. But you as a researcher, there is no magic happening, believe me. Your machine, your data, your software is only trying to understand the similar kind of variables, putting together in one basket and calling it as a factor. Is it clear, class? Okay. Naming them, the themes, the way that what kind of variables are coming together, which items are coming together, is it really making sense or not? All those judgment is actually the capability of the person. So naming factors depends on knowledge, judgment, and verbal abstraction ability than the mathematical expertise. Okay. So that is why, as an expert in your area, you need to understand the content in literature very well. You might be an expert in statistics, but unless you have a good trade-off of your analytical skills, statistics, plus your subject knowledge, this has to go hand in hand, right? That is why it is very, very important to have a right literature review, then only move ahead in your research exercise. Okay, so we will be doing EFA, right? But CFA is the factor structure explicitly hypothesized and is tested for its fit. CFA, I'll explain you CFA because I'm going to work on EFA part. CFA is something when you are using existing scales. So when people are doing research based on the existing scales, they don't want to develop their own scale, and there are well-defined scales for your research, and you want to see the correlations or the mediation of certain variables, the moderation of certain variables. You want to test the entire research model. Then we use CFA, confirmatory factor analysis. So the word confirmatory means already the scale is well defined, so we don't need to actually play with the items and all. So this is a well-defined 7-item scale, 5-item scale, and I'm more interested actually to see the relationship among my constructs. Okay. How do we do that? There are different methods, structural equation modeling, and for example, the softwares which can be used for this exercise called Lizral, Amos, and Smart PLS, right? Moving ahead to the factor analysis, right? Quickly, ideally 4 or more measures. So if you are planning, for example, how will I know that how many items should I develop? Any idea? How do you start with? If I say loyalty, and I told you how did I define loyalty. So when I was trying to define loyalty, I had some features in my mind. I was trying to see a sense of belonging, a sense of respect, a sense of trust, right? And a sense of security, for example. Maybe I had some 4, emerging dimensions coming from the literature synthesis. And I realized that, my definition is around these 4 dimensions. Then I think that there should be 4 dimensions. Okay, fine. But I'm not sure because I haven't done any factor analysis or I haven't collected data. But from the literature, my construct definition includes these 4 aspects. Okay. So basically, now I have writing certain items. So I wrote certain items, maybe 25 items. And now I'm trying to actually do the factor analysis. And I am trying to see whether what I'm thinking, what I could actually, get it from the literature, is it really aligned what people also think? How people think? People have given you the responses. Okay. So you start with certain idea. Maybe you are actually following the deductive approach, right? So you have done you have gone through the theory. You are now actually have certain observations, your own understanding. You have defined a construct, and now I'm actually moving towards to prove that whether my hypothesis is correct or not. Is that okay? Yeah. So moving ahead, results of the analysis should not be used alone in making decisions or for inclusions or exclusions of the item. As I said, it should have the right conjunction with the theory. Sometimes, believe me, machine is machine. Have you heard about this garbage in, garbage out model? GIGO, right? If you put the wrong data or the poor quality data, you are going to get poor results. So the quality of data is very, very important. At the same time, sometimes some random items actually club in a factor. So that also needed to be carefully reviewed before you include or exclude any item, right? So moving ahead, this is the research methodology for this particular scale development aspect. You can generate the items, you can do the content validity, you should add certain criterion variable, you should try to define context of the study, and then we are going to now explore the inter-item analysis, sampling adequacy, EFA, construct validity, external reliability, and the criterion validity, right? Moving ahead, we had already discussed it, right? And factor analysis is used for the data reduction, scale development, and evaluation of the psychometric quality of an existing measure. So basically, I would like to show you the, because if I discuss all this, it would be a little dry. So let me just show the example. You know how to import the data in SPSS? Dr. Satrajit?
Yes, ma'am.
Yeah, so is that okay if I directly start with the SPSS part?
It's okay for me, but I can.
Okay, so this is the data actually. So this is gender, this is 1, 2, 3. So management cadre of the employees. And I had collected data from L1 to, this is my
Yes, ma'am.
data points for L1 to, I have around so many variables. Okay, let me check here. So we have these number of variables, right? Till L56, right? Which also includes the variable for criterion validity. Okay. I'll show you something else so that it becomes easy for you to connect with the L1 to L56. So you can import data. If you don't know, you can probably watch a video. It's an easy thing to import data. Okay. Let me show you something. Yeah. So if you see on the screen, these are my statements, right? So I was trying to develop a scale on employee loyalty, and I had designed these items. I feel a strong connection with my organization. As I said, I was thinking in these directions, right? Something on belonging, willingness to stay, advocacy. The people, those who are loyal to the organization, they always talk positive about the organization, and interpersonal trust, that institution takes care of me and I am very much committed to my organization. Now moving ahead, see if you can you see the screen? Is it visible, that Excel sheet?
Yes, ma'am.
Yeah. So now look at the Excel sheet. I had included an existing scale of loyalty from item number 26 to 31, right? I'm convinced. So this is an existing scale of some author. And I had also included some criterion variable, perceived contribution to company value. We call it PCV. This is, so my hypothesis here is for criterion validity that employee loyalty will lead to perceived contribution to company value. How? I feel that I can contribute to the satisfaction of my respective customers. The majority here contribute to the organization's progress and financial results. So something which I feel that if I'm loyal, I would be actually contributing to the company, real company value. This is coming from literature. This is not my opinion. Okay. So it shows that if a person is loyal, it will be leading to the PCV, right? So this is how I had designed. How many items, if you can tell me quickly, how many items which I had planned for my scale? Till 26 items, right? 26 items. These statements have the content validity was done, and then we had moved towards the construct and the criterion validity. Number of items in the existing scale 27 to 31, so 5 items, and there is a criterion variable which has around 6 items, right? So this is how my L1 to L57 is till 57 is defined. Okay, so there were few more items. Actually, this is a part of a bigger research work. So from 31, the number has been changed, so no worries about that. But this L52, L53 is something from L52 to L57. It is more of the criterion variable. Okay. Now the same data has been imported in the Excel to SPSS. And if you see, okay, let me share the SPSS window. Yeah, I hope you know how to import it. Once you import it, you need to define the scales here, measures here. It should be scale. It is not ordinal. It is not nominal. So, for example, gender is a scale or is it a nominal?
Ma'am, nominal.
Nominal. So you change it.
Nominal, ma'am.
Management cadre is ordinal, nominal, or scale? Junior, middle, or higher? Ordinal, right? And rest of the variables are in the Likert scale. So they are all scale variables. Now, if you note it down, I had put there are 3 reverse coded items, L7, L18, and L25. Okay. Just remember these numbers, right? And we'll see how we actually go ahead to the data analysis, right? So go to analyze. If you want to note the command, please note it down. Dimension reduction, and then go to factor. If you go to factor, I had already taken these variables. So these all variables, it will look like this. So you need to just select all the variables till L56, yeah, and put it in the variable box. Go to the descriptives. I want KMO and Bartlett. That is the test for sample adequacy. Continue. And then in the extraction, we are not making any changes here. We are trying to see the factors based on eigenvalue. Then rotation, we are putting Varimax here, right? By default, it is none. So put Varimax. And scores, no changes. Options, yeah. In options, we have made a change, sorted by size and suppress the small coefficients 0.3. If I don't do that, I'll show you what happens, right? So I'm not putting this option on and then continuing. Click OK. Can you see an output window, or is it still the... If you see the output window, is it visible, the output window?
Yes, ma'am.
Yes, ma'am.
Yeah. So if you see KMO is more than 0.5, which means our sample is pretty much adequate. Moving ahead, if you see this table, total variance explained, it is, how many factors is it suggesting? Can anyone tell me with this table?
Ma'am, 36.
36, ma'am.
No. What are the factors suggested by this? Thirty-six are the variables, no?
B8.
What?
8?
Yeah, 8, right? Can anyone tell me what mistake did I do? So it means 75% of the variance is explained by how many factors? 8 factors.
8 factors.
Before I move ahead, can anyone tell me what did I do? What mistake did I make? I had selected all the items. But you remember how many items did I actually chose for the scale development? Did I choose to, did I keep 26 only? You remember that? I had included all the items. See, this is how you actually make mistakes, right? So I'm not going to the component and the rotated matrix. Let's go back. Go to the data reduction factors and only include the item till 26. The rest of the item should go back. because they are not the part of, they should not be the part of factor analysis. Is that clear? What changes did I make?
Yes, ma'am.
Can you see the output window?
Yes, ma'am.
Is it visible?
Yes.
The
Yes,
total
yes,
variance?
Yes, ma'am.
Yeah, because sometimes I'm not able to see, so please confirm what you are saying. Okay. Now, how many factors?
Ma'am, 6.
6 factors, and the total variance explained is 73, right? What do we do with this table? This table only helps you to understand that your construct is able to explain the 73% of the variance, right? Maximum it could be 100, but it should be more than at least 50% of the variance. Moving ahead,
Ma'am, Ma'am, what is the meaning of rotation?
Yeah. Why do we do rotation? See, with the help of rotation, you get the better estimates, right, of intercorrelated items. That's why we put rotation is nothing but the different combination of your data items which are rotated. I mean, with different kind of combinations are possible with the help of rotated component matrix. If you don't choose Varimax rotation, you will only get the component matrix, right? But we usually prefer rotated component matrix, which means it is giving you all possible combinations of your data set and then providing you the 6 factors. Okay.
Okay, ma'am. Thank you, ma'am.
Rotated component matrix, if you can have a look, there are 6 factors which are given here, right? And it has all possible. This is called loading. Somebody was asking me a question on cross loading yesterday. These are the loadings. Loadings is nothing but you can just imagine it like a weight. So maximum it could be 1 and the minimum it could be 0. So maximum loading, I mean the higher the loading, the better the item. Now if you see all 6, now ideally under each factor there should be unique items. Items should not be repeated. So if I say L14 should have a high loading in factor 1, but it should have low loading in the other factors. That means factor 1, L14 is strongly related in the bucket 1, factor 1, or whatever you call it. Okay. Now, if you see this matrix is little, complex, because we have so many values, minus, plus, including, and all the variables, all the loadings are here, right? So next, if you go back in your factor analysis table, in the options, if you go and you suppress sorted by size. So now, if you don't take this sorted by size, there will be random loadings, right? Random loadings, matlab, L23 can come up, L14, L20 can come here, can first come. So there is an order. See, sorted by size means 0.8, 0.7, 0.75. So there is a decreasing order of loadings so that it becomes easy to actually go through. One more trick if you can do, suppress small coefficients. I don't want to see the coefficients less than 0.4, for example. Right? And now see the difference in the output. Can you see another rotated component matrix with
Yes, ma'am.
with blank columns? Yeah.
Mhm.
Now
Yes,
look
ma'am.
at this. Now factor 1 is very clearly saying that L14, L4, L2, L1, L11, all these items are under factor 1. Similarly, the preferred loading or the cutoff value for the loading is usually 0.5, right? Note it down there somewhere. 0.5, if it is 0.5, we usually accept it. And if it should not be ideally cross-loaded. What do you mean by cross-loaded? That, for example, L21, it has 0.511 and 0.541 in both the factors. Where should I consider L21? This is an example of cross-loading. Is it clear? L21 has a cross-loading. Can anyone tell me some other items which are having cross-loading?
I'm L3.
L3, right. It has cross-loading, right? Very good. Okay. So what should I do now? I want a clear rotated component matrix. Each item should be only loaded in one factor, right? And I might also reduce number of factors because The moment you start merging some of the factors, because as I said, each dimension should have at least 3 to 4 items. But here, if you see in factor 6, there is only one item which has higher loading 0.77. So is it desirable to have 6 factors? My data is not suggesting it. Okay. What changes should I make now? Yes.
Ma'am, why we are having cross loading?
Why are we having cross loading? You tell me the answer. Think about this. Why one item is loading in multiple factors? Because that item was not very clear. People got confused, and that is why they have rated it in such a way that it is now loaded in 2 factors. So go back and check the language of that item. There is some problem. And the other way of doing it, because since you have included more number of items than required, because you wanted to have a buffer. You remember we discussed 2:1. If you want to discuss or develop a scale of 12 items, you should at least include 24 items. So this is the time where we are trying to reduce the redundancy and the overlap, and we are coming up with more clearer statements which can be part of your final scale. Am I clear? Is it okay? So this L21 is very confusing. So let's remove L21, right? Now have another look which I really want you people to explore. There are 3 negative items, reverse coded items. And I had again done a mistake here. I wanted to do few mistakes so that you people can correct me, isn't it? Now tell me some other mistake. I mean, this is very much visible in this sheet, in this table. Tell me if you can observe that mistake. There are 3 reverse coded items. That's a trick or that's a hint for the answer. L7, L25 and L18.
We are getting negative values for that.
We are getting negative loadings for that, right? And if you go back and check the Excel sheet, you will realize that I have forgot to
Change it, I mean.
Change it, right? I have actually used the same raw data which I had received from the Google Forms, right? I have not made these items regular coded, and you will realize and you will see it here. The moment you make it regular coded, the loadings would be positive, right? Is this okay? Is this clear? Can you make out this difference?
Yes.
Right? This is what I did actually consciously, knowingly, so that you can realize if you don't make these items regular coded, it will have a negative loading, right? Now, for example, now I'm convinced because this is the part and this was a dummy data, though it was part of my paper, but I had collected more data after that also to complete the paper. But if I want to, remove certain items, for example, I would like to remove, now these reverse coded items are not making sense because they are not correct in terms of values. And also I want to remove L25, for example, because in one category it is positive, in one category it is negative. And you remove all these items cross loading, and imagine, let's remove and then see the results. So I'm removing L3, somebody said, right?
Sorry, ma'am. Just a quick question, ma'am.
Yeah.
So, ma'am, every time is it necessary to, all the reverse coded item would be in negative, or sometimes that can also be in positive?
So see, if it is there, na, L25, it is negative in one category, it is positive in another category. But ideally, you should do this cleaning and pre-processing before you actually import the data in the SPSS. Okay.
Sure.
So now I'm going to remove, just to give you an idea, because we can remove, for example, L21, and we can also remove, I'm trying to remove, I mean, you should remove it one by one. So let's remove the same thing, go back, and L21, send back to his original home and click OK. See, now check if there is again still cross loading. See, L10 has a very strong cross loading. I'll remove L10, right? And then let's see if there is any change. Okay, so this is how you remove one by one and see the changes. And you also see whether the total variance explained is changed or not. It should not go beyond a certain limit, right? Now see, suddenly my factors have been reduced and it has become 5. So 5 concrete factors, right? But again, when you make these items regular coded and run it again, remove the cross loading, you will finally get 4 factors. Now just see if it is explaining 71% with 5 factors, and if I actually put, because my theory is saying there are 4 factors, right? So can I fix number of factors? Yes, we can, because it is suggesting 5 with 71% variance. But I want to get 4 factors, right? I'm fixing the number of factors in this category. And let's see with 4 factors how much variance is explained. Why do I need to have? So now it is 66%. And with 4 factors, if you see, at least in number of each factor, there are at least 3 items, right? Now the entire exercise is now to be done on the basis of this, right? Rotated component matrix, right? Is that okay? Should I move ahead?
Yes, ma'am.
So there is, now we are getting unique factors which are explaining 66% of the variance, right? And at the same time, I have got a more clearer rotated component matrix. Don't go by this particular answer, table, because as I said this is a dummy data. So I just wanted to give you an idea how do we do that. Okay. Now moving ahead, you can just copy this, right? We need one more exercise to see, because if you remember in criterion validity, okay, let me come back to the point where we will be using rotated component matrix, right? So for sample size, as I said, the what did we calculate for that? The first one, Kaiser, yes, KMO was should be more than 0.5. So it was pretty much okay for our sample. So this also gives you the idea of sample size. Moving ahead, Bartlett test of sphericity, it is important to see whether this test is significant or not. So the p-value should be less than 0.05. This basically tells you that your component matrix, the item correlation matrix, is not an identity matrix. So items are not highly correlated. So this is the assumption. So we are just trying to reject the null hypothesis by saying that my item correlation table is not an identity matrix. If you don't want to get into this kind of complexity, just remember Bartlett test of sphericity should be significant.
Ma'am,
Yeah.
ma'am, why p-value should be less than 0.5?
So we are rejecting this hypothesis that this item correlation matrix is an identity matrix. That was our null hypothesis. We are not saying our item, because if items are highly correlated, if it is an identity matrix, which means all the diagonal values are 1 and all the other values are 0, right? Are you saying that? No. So we want to reject this null hypothesis and want to accept that this is not an identity matrix. The items are correlated with each other, right? But not 1-1. Okay. Moving ahead, I hope I'm clear.
Yes, ma'am.
Yeah. So even if you don't want to get into that complexity, I always give a second thing to the class that you will, find it out. But at least remember the basic thumb rule is that Bartlett test of sphericity should be significant, right? So that means the p-value should be less than 0 so that we can reject the null hypothesis, right? That's the first step to move ahead in the factor analysis. We have done all these 4 steps, right? First step, the correlation matrix for all the variables is computed, right? Which was there in the output sheet. The second step is factor extraction. The third is factor rotation. And the final is making final decisions about the number of underlying factors. So we made the decision of 4 factors. We have done all these things, right? Now, the correlation between variables are small. It is unlikely that they share common factors. They should not be related. I mean, they should not be related. If they are not related at all, if it is an identity matrix, will you get factors? Tell me. If they are not related to each other, if it is 0, 0, item 1 to item 3, item 1 to item 4, if it is not related, will you get common factors?
No, ma'am.
No. So you have to have the correlation. It could be low, it could be high. So if the correlations between variables are small, it is unlikely that they share common factors. So the correlation coefficients greater than 0.3 in absolute values are indicative of the acceptable correlations, right? We had not discussed this, but this is the first part of the first step of the factor analysis. Moving ahead, we used Varimax rotation, if somebody could recall. So factor extraction, there are different methods. Usually we take the, which method usually we follow? Principal component analysis, right? I don't want to get into details because usually we follow this method because this gives you the most optimum results. Moving ahead, the factor extraction, we try to give the maximum linear combinations of the variables coming together, making a group and giving you the factors, right? This is the total variance explained table. So with this, if you can see, there are 3 factors suggested for this particular data set, which is explaining 58% of the variance. Another method of factor extraction is eigenvalue. We are skipping it because sometimes scree plot, we are skipping it because scree plot sometimes gives you Confucius results, right? We are following the first method, which is eigenvalue. So any factor which has eigenvalue more than 1, we consider it. If you see in this case, there are 3 factors which has eigenvalue. These are the eigenvalue components. So initial eigenvalue. So this is, if you see, 3, 1, 1. So we are considering 3 factors here.
Ma'am, what is eigenvalue?
Eigenvalue is something which you calculate it with the help of the variance explained. So the variance, if you see the second column, the percentage of the variance, it is actually the ratio of the total variance explained by that particular item. So the maximum the value, which means it is actually giving you an integral part of your factor. Okay, so if you see 3, 1, 1, which means the eigenvalue more than 1, which means there are 3 factors. If you see for the rest of the variables, right? So basically factor analysis start with the assumption that if there are 10 items, there are 10 factors, right? But we don't want to have 10 factors. We want to reduce the data. That is the data reduction technique. So we are trying to reduce those 10 items with the help of these 3 important factors, right? So with each item 1, 2, and 3, now in these 3 items, so these are the, you can see monitor of the class, right? So now I'm saying there are 3 classes, right? 1, 2, and 3. Now rest of the item will go in each of these classes, 1, 2, or 3, 1, 2, or 3. Okay, we cannot have 10 classes, so we cannot have 10 monitors. So these 3 have emerged as monitor. Rest of the class will join these monitors. Is that okay?
Just a minute, excuse me.
Yeah.
Ma'am, ideally, what percentage of the variance should be explained by the factors?
Minimum 50, more than 50%. There is no specific cutoff, but at least more than 50% with the suggested number of factors.
Okay, ma'am.
Yeah. So moving ahead, rotation. As I said, we usually assume that your factors are not highly correlated. Orthogonal. So there are 2 techniques, right? Orthogonal Varimax rotation and oblique rotation, right? If you remember, we have chosen Varimax because Varimax, the underlying assumption is the factors are not highly correlated. Orthogonal and oblique. When factors are highly correlated, we use oblique rotation, right? Under oblique rotation, the technique name which we can use in the SPSS is called ProMax. Now, this is not an assumption. I had already seen whether my factors are highly correlated or not. I will run it through oblique rotation once more because I would like to show you how do you get the component correlation matrix. Remember this word. Component means factors correlation matrix, right? So till now we had run rotation, which is the orthogonal rotation, following it with the help of Varimax rotation. Now I'll show you how should you run the oblique rotation, because once you run the oblique rotation, then only you get the component correlation matrix. Yes. No, I'm not sharing I'm sharing the slides if.
Ma'am,
Yeah.
ma'am, like in reliability, we have three methods to check reliability: inter-test, inter-rater, retest, retest. And why only we consider Cronbach alpha?
Okay. So see, each method has its own limitations, right? So the most relevant method, I'll say, is in the sense which is most feasible and practical in terms of conducting it. Now, test retest means, would you do multiple times the test to see the reliability? एक बार ही भरवाना इतना मुश्किल होता है किसी रिस्पोंडेंट से. Tell me how practically, what is the practicality of getting test retest? It's very difficult to get the data filled by same set of person, right, and test whether they are highly correlated or not, right? Parallel forms is another method, but parallel form again creating similar kind of questions, right, in two forms, alternate forms or parallel forms. It's difficult from the researcher point of view. That is why we don't usually do that, right? Then the third is test retest, right, which is a test retest done, parallel form done. We do it split half, right? Split half, we do it. I'll tell you why do we prefer to do that. The last was inter-rater. Do you have time actually to get it filled up wise the same questionnaire, assessed by the two raters and see whether they are highly correlated or not? So the test retest is by the same respondent, but inter-rater is something same questions given by by set of people, by the experts, two experts. It is only possible especially for the objective kind of test, right? Because you do understand the personality, employee engagement, or any work related attitude, there would be significant difference with the individuals. But for the some kind of objective test, when there are unique answers for that, then you prefer to have intra-rater. So that's why the purpose of these methods is different. Some methods are not preferred because the feasibility part. A split half, which is called Cronbach alpha, is an most feasible, or what should I say, most practical method of calculating reliability. Because what do you do with the same set of data, with a single respondent with same form? You just divide number of items and you try to see different combinations of items. You can divide it in the even and odd form, or maybe alternate ways. If there are 10 items, you divide it by 5 and 5, and you want to see if it is the same construct, the correlation from the first 5 items with the second 5 items should be high, right? So that is why we use split half method, and SPSS is tuned in that way only.
Okay, ma'am. Thank you so much, ma'am.
Yeah. So moving ahead, there are two kinds of rotation. Just remember these two things: orthogonal and oblique. Under orthogonal, the test technique is called Verimax. Under oblique, it is called Promax, right? Which is I'm going to showcase you in the SPSS. Okay. I did not know that I had missed out these things because I was not sharing the slide before that. So these are the things which I had just explained and I am sharing. Okay. So now I'm going back to the factor analysis part and showing you how do we, right, do the construct validity, right? Now remember this, for convergent validity, the average loading in the pattern matrix or in the rotated component matrix should be more than 0.7, right? Remember this cutoff value. And the discriminant validity, the variance extracted between the constructs should be more than correlation between the components, right? I'm stop sharing my screen and I will be sharing the SPSS, okay? Right. So now, as I said, we have not got the component correlation matrix, right? So for component correlation matrix, I just want to know whether my factors are correlated or not, because I have not tested it. I am just assuming my factors are not correlated. How would you compare? Because now there are 4 factors and let's see whether my factors are correlated or not. So the factors, if I go to rotation, as of now, I have ticked the very max. But as I said, the oblique method has Promax, and let's see if my factors are correlated or not. Now this is component correlation matrix, right? Now if you can see the component correlation matrix, the components are not highly correlated. So it's 0.529, 0.409, and the fourth one is 0.101, right? So you need to actually copy these component correlation metrics in your Excel, right? If you are calculating the criterion related validity. And you also need to copy this rotated component metrics in your Excel so that you can do the necessary calculation. Okay. Okay, don't cancel. Right. So why did we take Varimax rotation? Because our components were not highly correlated. So now I would like to show you the paper which had published this part, right? And I had shared it. I hope the participants have got that paper, Satyajit.
No, ma'am.
So I had shared that paper with the STTP team. I just hope that you can, if you can access that, I'll send it to you as well if you want. So who is coordinating it? You can just ask them.
Yes, ma'am.
Yeah, so can you please, I had shared few papers yesterday for the participants. If you can share that, that would be great.
Yes, ma'am. I will share it.
So this is the paper. Actually, this is the paper where that data which I was showcasing was used. And can you see the paper?
Yes, ma'am.
Right. So this is how I had started this paper with the concept idea, right? How did I actually come up with the construct, which is that why are we doing that research? So this is how you did the research, defining loyalty. So with the help of, the person who has coined this term first time, they had developed certain, there are a few people, those who had developed the scale. I showed you the existing scale, right? But I was not convinced. So we thought that, synthesizing the literature, there should be some dimensions of ownership, trust, and willingness to stay, right? However, we are not very sure whether these are the right kind of, dimensions, which should also be whether they are aligned with our data set or not. We wanted to get some evidence for our scale. So we had collected data. These were the dimensions which we started, right? Then we had actually did the item generation, did the content validation, right? So we had started with, as I said, 26 items. We also added 5 items from the employee loyalty scale, existing scale, and 4 items for the PCV, perceived contribution to the company value, right? And this was our sample demographics. We had also studied the item total correlation, that all the items should be related to each other. If they are not related, you will not get the factors, isn't it? So items should be correlated with each other, right? We had calculated kurtosis also, just to see, and skewness, to see whether it has external validity or not. If you read this paper carefully, because we don't have much time, so you can just have an idea, how do we calculate this. This is a very detailed paper. KMO, as I said, it should be more than 0.5, so sample was pretty sufficient. This was the descriptive analysis and inter-item correlation. As you see, these items were correlated, right, from the overall factors, right? These are the overall factors, 3 factors: sense of ownership, willingness to stay, and trust. So if you recall, we started with 6 factors, then we had curved it to emerged into the 4 factors, right? But finally, when we did multiple round of iterations, we had been frozen by 3 factors, which are 3: the sense of ownership, willingness to stay, and trust. We had also realized that how these factors are related with the items. Now, if you see that the factors for particular factor factor are highly correlated with their overall factor, right? This is not rotated component matrix. This is not loadings. This is the correlations which are significant, right? So these items are correlated because overall they are measuring one construct, second order construct, which is employee loyalty. Now these are the items, right? This is the result of EFA. This is rotated component matrix. Now if you realize it, sense of ownership, it has all high loadings under this factor, right? These are the items compared with respect to those, particular items, right? These were the statements. And if you see for factor number 2, which is willingness to stay, the 3 items were loaded, rest of the items had low loading. And for the third item, for the third dimension, which is trust, we had 4 items. Okay, so we had discussed the descriptive analysis and inter-item analysis. Reliability, I'll show you again when I go back to the SPSS window. For construct validity, as I said you, the cutoff value should be more than 0.7. What cutoff we are talking about? Cutoff is nothing but the average loading. So now if you see, this is the average loading. For sense of ownership, if you average it out, so all the items under which, sense of ownership, if you calculate it, you will find a convergent validity value, which is more than 0.7. Similarly for second factor and the third factor. So I had already made that table. Yeah, this is here. So the convergent validity of all these 3 factors is more than 0.7. And the correlation with the existing scale, that is another way. We had used 2 methods of convergent validity. So this is second method of seeing with my existing scale whether these factors are related or not. If with my existing scale, if the factors are related, what can I conclude? If that scale is valid, my scale is also valid. So this correlation with the existing scale is significant. For discriminant validity, now listen carefully, the table which we had calculated, the correlation, component correlation matrix, we try to calculate the variance, right? So variance, this is the variance which is coming from the loadings, average variance, right? So this is coming from the loadings. So if you see the component variance table, you will find that variance in the output and average AV between the components. So now this AV between the component is nothing but 0.527 plus 687 divided by 2. You will find the between the component, and the acceptable condition is it should be more than the correlation between the factors for the discriminant validity. Another way you could also be calculate the discriminant validity by saying that we had another component called perceived contribution to company value. It's a distinct construct, right? And if you want to showcase another evidence of discriminant validity, you can see that the correlation between the R factors should be low with the per PCV. So simple correlation coefficient. I have not done that, but you can also do that, right? Then I'll share a few video links which has explained these 2 things, convergent and discriminant. And the last part is the criterion validity. You remember what criterion which we had used or included in our scale questions? Can anyone tell me? Perceived contribution to company value, which is PCV. And we are trying to just see our overall scale, which is employee loyalty, and 3 factors. How much explaining, how much R square, which is the variance explained, is, or what is the correlation, what is the coefficient, beta coefficient for these variables with the PCV, right? My dependent variable is PCV, which we had indicated as PC. So basically for criterion validity, there are 2 things which you need to consider. The beta coefficient, which is significant if you see, with all the EL and all the 3 components, and the R square value. I suppose we had mentioned, must have mentioned that value. It should also be significant, right? Significant in the sense if my loyalty if my loyalty component is able to explain the variance of TCV, that means we have the criterion validity, right? See, this is the criterion validity component. So yeah, R square value is 0.603, right? So which means 60% of the variance is explained by employee loyalty of what? Of perceived contribution to company value, right? This is how you can calculate content, construct, and criterion validity. For content validity also, I had written it, though I had not explained it. But content validity is very simple. You just need to collect data from different experts, and you just need to calculate Cohen's kappa value. Okay. I'm sure I must have, yeah.
Ma'am, what is the interpretation of degree of freedom 91 in the table given in this paper?
Which one? Where?
In the above degree of freedom, it was given 91.
Okay. So basically 91 is degree of freedom is n minus 1. So yeah, this, right? So basically it is saying that you had 92 combinations, variables, right? You are just trying to calculate the, with the help, these are the possible combinations. So sphericity is nothing but, as I said this is the inter-item correlation, which is not an identity matrix, right? So it is trying to actually calculate the difference from the identity matrix with your existing matrix, right? So now, degree of freedom, if in the simple terms, if I can explain you, it is nothing but the number of variables which are actually can be utilized for doing this this test, right? Chi-square test, right? So this is n minus 1, which means it had 92 variables, right? Variables, when I say, it means the combination of those inter-item correlation, because I had used around 26 items, if you can remember, right, for analyzing this table, right? So degree of freedom is n minus 1. So with 91 constraints, 91 number of variables, it could actually give you the combination to test what is the chi-square value. Okay.
Okay, ma'am. And ma'am, what is the interpretation of B values and beta values? What is the difference between the two?
Yeah, so this is one is a standardized coefficient and one is unstandardized coefficient, right? This is nothing but the regression result, beta. So regression is unstandardized, means it has not been divided by the standard deviation. Beta means, see, this constant is not coming in the beta, right? This table. So when you write the regression equation, you remember we write y equal to a1 plus b1 x1 b2 x2. So this is a1, right? If I write this equation here, that would be plus b1 x1 b2 x2 and b3 x3. But standardized coefficient, you just divide it by the standard deviation, you will find the standardized coefficients. Okay. So the beta value should be significant for the criterion validity.
And ma'am, is there any cutoff point for T values? Like somewhere it is 2, somewhere it is 10, somewhere it is 1.
Right. You remember it should be more than 1.96. And from where this word is coming, this is the T statistics. For 95% confidence, this value should be more than 1.96, right? And that is why, if you see, it has been translated into p value. So 1.727, which is less than 1.96. That is why it is significant at 92% only. It is not less than 0.05, right?
Yes, ma'am.
Yeah, it is actually nothing but the translation of T statistics only. आपने क्वांटिटेटिव एनालिसिस में या क्वांटिटेटिव टेक्निक्स में ये सीखा होगा हाउ द टी स्टैटिस्टिक्स इज कन्वर्टेड इनटू p value. Okay. You want me to explain reliability? How do we calculate that?
Yes, ma'am.
I know it's little heavy for the entire class because this course is covered in 30-hour session. But Professor Satyajit had requested and I could not say no because that's my interest area. You can go through the papers. I would also share some of the links which will help you if you are planning to develop a scale or something, right? But feel free to connect with me if you have any concerns or if you are facing any issue when you are developing a scale. Otherwise, in my papers, it's very much explained. So you can have a look on that. So the last part, I mean, we have 10 minutes. I wanted to give you some time to, if you have any questions to ask, but I will just show you how do we calculate the reliability, right? I forgot exactly under which. Can anyone help me in which category we used to calculate reliability? I forgot actually how do we which column it was there. Yeah, scale, right. If you go to scale, right, now just give me a simple, can you see an output window of can you see SPSS window?
Yes.
Yes, ma'am.
Now it's a little tricky, right? Okay, so let me come back to the class. Tell me, if how would you, for what we calculate reliability? For the constructs or for the overall scale or for different constructs together? What items should I put when I'm calculating reliability?
All the items used in a scale.
Why should we keep all the items? Do you
Because
think
we
all
want
the
to calculate the consistency of the scale?
Yes, so that's a one way of doing it, right? Consistency of the scale. But do you think in my scale there are three dimensions: sense of belonging, trust, and willingness to stay, right? Don't you think that we should try to calculate the reliability of each factor? Because under each factor the items are highly correlated. Okay.
Yes, ma'am. Can be done like both ways.
We should do that. In my paper also we have shown it both the ways, that for each factor the factors are reliable, and overall, because it is actually the part of overall scale, so my overall scale is also highly reliable. So you are correct, actually we should do it both the ways. Okay, so now I'm just trying to give you an idea, I mean just a random idea of saying that we are trying to calculate the reliability, but for that you need to put, I'm putting random items, for example L1 2 3 4 5, right? These items I'm calculating alpha, which is split half reliability, and click OK. You will find the value of reliability, which is for 5 items my reliability value is 0.829. Okay, you need to do it multiple times, and you also, if you want to calculate the reliability of overall scale, you need to put all the items together, right? If I can put all the items together, maybe L till L26, but I'm just putting it randomly because, as I said, it's not the correct, the selection of the items is not correct. So if you see, the overall reliability is 0.886. Okay. So this is how you calculate reliability. Do you have any questions?
Ma'am, there's in regression output, there's a term Durbin-Watson.
Yeah.
Ma'am, can you explain, ma'am, in brief?
Okay. Okay, give me a minute. I'll just check in which context it is written.
It is for autocorrelation, that I vaguely remember.
Okay. I just missed it. Let me just see where are you referring it. Okay. I'm showing you the paper. Tell me which page you are referring.
No, ma'am, in paper it is not there. But in regression output, generally we see that there is a link Durbin-Watson.
Durbin-Watson is a technique, if I'm not wrong. Let me just check. Durbin-Watson.
Below the residuals, it is written.
Yeah. So, presence of autocorrelation in a regression is a at lab 1. Okay. See, basically in regression tables, if they're autocorrelated, right? If there is high autocorrelation, that is the test for Durbin-Watson, right? So if in factor analysis, the items should be highly correlated, should be related. Otherwise, you won't be able to get factors. But in general, if you are taking, for example, in regression, if you are taking 5 independent variables, should they be highly correlated?
No, ma'am. Independent variables, ma'am, it should not be
It should
correlated.
not be. So that is what is Darwin-Watson test is trying to tell you, that whether your independent variables are auto-correlated or not. Okay, whether they are related with each other or not. So it should not be highly correlated. I remember there was a test actually to do that. So this is what the test is. Okay.
And ma'am, there is also a term residual we use.
Residual is something, for example, when I say my 4 factors are able to explain 73% of the variance. So the rest of the variance is actually because of the residuals, right? So that residuals is something, sometimes you call it error also, right? So because of certain other measurement error, some of the variance was not explained. That is called residual. Okay.
Okay, ma'am.
Any other questions from any other participant?
Ma'am, when we say a scale variable, then it is a metric variable, or ma'am, it's a variable that we measure on a Likert scale or some other scale?
That depends. Which scale you are using, right? Mostly in social sciences, the scales are in Likert scale. Interval scale, we call it interval scale. But I had developed an employee loyalty scale in a 5-point Likert scale. Sometimes the indication of those Likert values are different. Sometimes it is from not satisfied to very satisfied in a scale of 7, in a scale of 5, or in a scale of 6. So that also depends that how have they developed it, right? The person who has actually started or has created that scale.
Okay, ma'am. Thank you so much, ma'am.
Okay. Any other questions? Okay. So nice to interact with all of you.
Ma'am, one last question.
Yeah.
So, ma'am, in most of the research papers, we see that the hypothesis is formed in a null form. Ma'am, in very few papers, the hypothesis is formed in an alternate form. Then, ma'am, why it is
No.
that?
But I disagree with that. I mean, null hypothesis is usually done when we are doing the statistics courses. To be honest, in research papers, we only talk about the alternate hypothesis. Only alternate hypothesis. We don't write null hypothesis in the research papers. For example, if my research paper is testing a framework which is saying employee engagement leads to performance, right? So my hypothesis would be employee engagement is positively related to performance. Null hypothesis would be there is no correlation between employee engagement and performance. Have you seen that? No, I don't think so. In research papers, we only talk about the alternate hypothesis, whether it is accepted or rejected.
Then, ma'am, we should frame the hypothesis in alternate form.
We do
in
that.
research
No.
paper.
So research papers, we only see in any of the research paper, with my limited experience, I had seen it in 95-99% papers, only alternate hypothesis is showcased, which is like employee engagement is positively related to employee performance, employee engagement is related to organizational commitment. So we are trying to say it is related, it is positively related, which the direction which is coming from the literature. Null hypothesis would be, what would be the null hypothesis in this case? You tell me.
Ma'am, that employee loyalty is not significantly related to
Not related to, yes, employee loyalty or employee engagement is not related to performance. So we are not saying that. We are saying it is positively related. We are using actively null hypothesis only. Alternate hypothesis only.
Okay, ma'am. Ma'am, thank you so much, ma'am.
Okay.
Thank you, ma'am.
Any other questions? I know it was little heavy, and had it been a SPSS workshop, probably could have been done for 3-4 hours. Though you could have done it in an hands-on setting, but with the limited constraints of time, I just wanted to give you a thorough, understanding of how do we develop scales, how do we actually prepare for a new construct, right? By the way, in your research, if you are planning to develop a scale, this itself is a thesis. So take a call, if you want to develop a scale. If you are very much convinced with the idea that this is a very unique construct and this is the construct where I need to develop a scale, then only develop the scale, right? However, if you are interested in doing research, right, and if there are existing scales, number one, first explore those scales, right? Unless there's a significant lacuna in that scale, then only you go for developing your own scale. Otherwise, I usually recommend students to use the existing scales, but use an existing scale which is a classical scale, which is very quality scale. It should not be an adapted or modified version. Use the original scale of the author. Okay. Then it is easy to actually go ahead with the SEM part and all.
Then, ma'am, we should adopt it, not adapt it.
You should adopt it, right, as per your context. You can do that. That modification is possible and it is desirable at times, because sometimes you need to make those small changes to contextualize it to your study. But when you are developing your own scale, that is a tedious exercise.
Ma'am, then if there is an international scale available, then also we should adopt it in Indian
I
context.
don't think unless it is in cross-cultural study, most of the time the scales, language, or the statements are very neutral, very standardized. You don't need to change those language. Don't make any changes, because you need to justify those changes also. So don't make any unnecessary change. If it is okay with the language, if people are able to understand in the pilot study, don't make unnecessary changes. Because people understand English, right? So the scales are in English only. If it is an adapted scale of any other language, then you need to test it before you actually conduct it for the overall sample. Okay. So thank you so much for the great audience, quality questions, right? And listening it carefully and keeping me, motivated by asking the questions. So thank you for the interactive session. Thank you for giving me the chance to speak to all of you. I hope this session really helps you in your research journey. Thank you so much.
Thank you, madam. This is Satyajit again, and thanks for your informative and interactive session. It's really informative. Thank you, ma'am.
Thank you.
Thank you, ma'am.
So I hope, I assume there are no more questions. So yeah, Apurva is back.
Appealingly pointed out by ma'am, I would like to express our deep thanks on behalf of Birla Institute of Technology, Lalpur off campus, to our guest Dr. Swati Dhir for such an amazing and informative presentation and giving us an insight on this relevant topic. I would also extend my gratitude to Dr. Vandana Bhattacharjee ma'am, director of our center, for providing us such a platform. My sincere thanks to director is directed to Dr. Satyajit Chaudhary sir and Dr. Syed Anis Haider sir, who took efforts to organize this event. Special acknowledgement to all my faculty members for joining this session and making this a great success. I also thank the committee members who contributed to this event. I would also like to express my gratefulness to all the attendees for taking out time and supporting us in our endeavor. We look forward to conduct more such events hereafter and hope ma'am will join us in future also.
Yeah, sure. Even if as a research scholar, if you feel if there is any problem which you are facing in your own research, proposal or your thesis, feel free to connect. I mean, the world is so small. So if you are stuck somewhere, sometimes, seeing the same problem multiple times actually exhausts you. So getting some points of view from the others, from the experts, I mean, that might really help you. So I am not an expert in statistics, to be honest, but I had some understanding about the research methodology part, and that's why I agreed for these sessions. So feel free to connect with me anytime, right, over mails. I mean, I'm there to help you if I can.
Kindly share your email ID.
You want it to be shared here only? Okay. I'll write it in the chat box. Yeah. Even I can also share the link of my papers because they are available in the Google Scholar. Yeah, this is my ID. You have another session after this, right? So I would be leaving the meeting.
Ma'am, please share the link of your papers also.
Okay. Okay.
Yeah. Thank you, ma'am.
If you just search in the Google Scholar, all my papers are there.
Okay.
Yeah, I mean that would be easy for you to see because there are multiple papers on even the scale development. There are 3 papers.
Okay, ma'am. Okay.
Yeah, I'll share this link which is there available, loyalty one, which I was discussing in the class. So this is the link. Click this link whether it is working or not. This is a PDF link. Yeah. It's working, Satyajit?
Yes, madam.
Yeah. So you can save
It's working.
else you just write my name in the Google Scholar. You will find all my papers there. Okay, so that will be helpful because then what I'm saying is there in the paper itself. Hello, great. Thank you everyone. I would be
Thank you.
leaving the meeting. Yeah, bye. Take care.
Thank you so much, Farhan, for such a nice introduction. And thank you so much. I can see Satyajit sir here. So good morning, sir.
morning,
And it's
madam.
always a pleasure, coming back to BIT because I have been associated as a student since 2006. So it's like coming back home again. Thank you so much for this opportunity to the hosts here. So I was just there during this session, which you all were having last 25 minutes. And I could see a great session going on. Congratulations to the team for organizing such a great, session. And especially because, like what I can see, we have some research scholars, we have some postgraduate students, some faculty members, and being a part of management domain, social science domain, research, methodology, business statistics, analysis part, all this thing play a very important role, especially when we plan to do any kind of research, be it for our PhD degree or otherwise. Social science researchers are always helpful for the society at large. I'm sure you all will agree to it. And if you have a knowledge of how to go about it, it always helps. Yes, of course, with the changing times, we have a lot of softwares, lot of websites, which helps you to do all these calculations. But then if you don't know the basics, if you don't know which test to use when, you will be at a loss. So even using the softwares intelligently, using the various calculators which is available on the websites, the theory part is very important. So after that very heavy session on the data analysis part, let me get back all of your attention to the research methodology process. So I was just going through the content, and I can see that you have already covered, how you, first of all, the first step which we take, that is defining the research problem. So that is one of the most important part, and to be done very diligently. And you have the whole plethora of knowledge from where you can, take in the primary and the secondary data for your literature review part. Of course, then you moved on with your attitude measurement and scaling techniques. You've also discussed about how to design your questionnaires by Swati ma'am, which, the sessions were great, and you had some a brush over the analytical part as well with ma'am. So now when you talk of research methodology, the first step, of course, will be defining the research problem. The second step, of course, is literature review. The third part is, you plan. There is a step-by-step process of how you move about research methodology. You cannot go in a haphazard way that, okay, first I'll do this, first I'll do that, then I'll do that. Believe me, being a student of MBA, we didn't know, of course, after learning, we got to know, but then initially we didn't know. Sabse pehle what we used to do, we used to decide about the hypothesis testing. See, the hypothesis bana liya. So that way it doesn't help. You need to move step by step to actually understand where your research is going around. And you as a researcher have to be very confident with what you're doing. So now we'll, after you have decided on, which methodology you'll be using for data collection, you have discussed in detail about questionnaire designing. There are other data collection tools like, observation method, interview method, a few of them extra more. And then what you do before even that, in your research design part, in your initial parts, you have decided the population on which you'll be doing your research. Right. So let me just share the presentation and then I'll go about. Let me know if the presentation is visible. Is it visible to all?
Yes, madam, it is visible.
Thank you, sir. Thank you. So, apart from what is written on the slide, we'll just go, since the topic itself is basics of research methodology. I thought, going into very high level is the next step. The first step is to understand what exactly the whole research methodology is. If you know the basics, the high level are easy to understand. So when we talk of conducting a research, collecting data, now you are done with, decided, and you have prepared, you have constructed your scales, you have created your questionnaire. Now what? The next step is you start collecting data. But from whom is the next question, right? You keep on asking such questions with yourself. So the best, the 100% accurate result you will only get when you do a survey on the whole of population, right? Now, what is a population? What is a sampling frame? What is a sample? We will discuss all this in detail now. Now, when you think of conducting a survey and you decide to do it on the whole of population, of course, that will give you quite an appropriate answer. But then, is it always feasible to do a survey on the whole of population? If I tell you to conduct a survey on, people living, Indians living in Switzerland, is it possible to do it? Now, if you, as a researcher, you'll have to travel, you'll have to see, you have to go collect data. So it's not always possible in that way. So in that case, what we do is, out of your target population, we select a small sample, and on that sample, we conduct all the analysis, and then we ratio it, we map it to the whole of population. So that is where exactly sampling comes. The simplest example which I can give you for sampling is, when you or your parents must have gone to a grocery shop to buy rice. There must be a lot of sacks kept there of different qualities of rice. Now, what your father or your mother used to do would be to pick up few grains and then just check the quality. And then he or she decides, depending upon the price and the quality, as to which rice, 50 kgs, 40 kgs will he or she buy. Now, that is the simplest way of understanding sampling. Seeing few grains, you're able to conclude as to about your decisions. So this is how sampling is done. Now see, here is the image which will help you to understand what is a population and what is a sample. So each element in your population is could be a part of your sample. So why do we need sample? What is the need to do a sample? Why can't we do it on the whole of the set? Like India conducts census every 10 years. Why can't we have that for all our research? Of course, the first reason being that it's impractical to do it for everyone. Second, budget can be a bigger constraint when we, plan to do data collection. If I tell you to find a survey for all Indians, so it will take a lot of time and a lot of budget for you to move from one place to another. Right? And then results from data collection are needed quickly. Many a times, we Indians are always in a hurry. We cannot wait for the results. We cannot wait for a long time. So many a times, we need results very quickly. So those are the times when data collection from a sample is always easy. Now, population, as in what you have heard about this word from your childhood, is always related to people, human beings. But in research methodology, population could be anyone. It could be objects, it could be organizations, peoples, or even events. The whole of organization could be one element of a population. So you need to be clear that population here doesn't always mean human beings and one person at a time. It can be objects. It could be balls kept in a big bag, or it could be organizations, the multinational companies around, and each company could be one element. People, of course, and even events could be one sample. So if suppose you want to do a kind of a research, a historical research on the independence, the various struggles which were done by freedom fighters, and you decide to pick up few events from that, so that again, those events will become the elements. Right? So anything and everything could be an element of your population. Now see, this is the difference between a population, a sampling frame, and a sample. These are some terms we get confused with. What is a population? Why is your teacher or your guide telling you to first frame your sampling frame? Right? So what exactly is a population? A population is each element which is there in under your study. That every element will be population. Now, from this population, the group of elements which are of interest for your research will frame the sampling frame. And then from this sampling frame, the few elements which you have selected to study will be a part of your sample. Right? Is there any doubt till here? Any confusion? Anything you would like to ask? Okay, great. So no questions means that things are being clear to you all. Now, populations can have the following characteristics. Population can be homogeneous, that is, all cases are similar. Like, in a factory where they are manufacturing same kind of products, it could be a homogeneous population. It could be stratified. That is, population can have different stratas or different groups. We'll be discussing what the word stratified means later. So that is again where, stratas could be one characteristics of a population. People could be from different levels of income, like low, medium, high. There could be proportional stratified. That is, there are stratas, but with different known proportions. The word known is important here because you know the proportion of each strata in your population. So percentages of different nationalities of students in a university could be an example of proportional stratified population. Next, grouped by type. Suppose you have grouped your populations according to some type or some distinct characteristic, like say towers, villas, villages, blocks, something like this. Grouped by location, again, if you are geographically dividing your whole population, so population could have all these characteristics, right? It could be homogeneous, it could be stratified, it could be proportional stratified, it could be grouped by type, or it could be grouped by location. Now, once I hope it's clear to you as to why we do sampling. Why we do it? We do it for the ease and the convenience to get our results. Next is why and how do we do sampling. So why is clear as to why we do sampling. The next is how we do sampling. There could be different ways of conducting sampling methods. So sampling methods could be probability sampling methods, or it could be non-probability sampling methods, right? So you have two types of sampling, that is non-probability and probability. Under probability, you have simple random sampling, you have cluster sampling, you have systematic sampling, and you have stratified random sampling. And under non-probability, you have convenience sampling, judgmental sampling or purposive sampling. You have snowball sampling and quota sampling, right? When we talk of sampling here, why do we differentiate it as probability sampling and non-probability sampling? Now, probability sampling techniques gives the most reliable representation of the whole population, and the non-probability sampling relies more on the judgment of the researcher, or an accident cannot generally be used to make generalizations about the whole population. So as a researcher, I will suggest you don't go for non-probability sampling unless, of course, required. You will always try to opt for probability sampling. Now, this is the theoretical definition. Probability sampling, in simple words, each element of your sampling frame of your whole population has equal probability of getting selected in the sample. And that probability is also random. That means each element of your population has equal chances of getting selected in the sample, right? And this selection is completely random. There is no link or there is nothing in between. And non-probability sampling involves that some elements of the population have more chances of getting selected or more probability of getting selected than the other elements. So that is what we are discussing here. It is a sampling technique in which sample from a larger population are chosen using a method based on the theory of probability. So what does the probability theory says? Equal chance to all, right? So that is what we'll be doing here. For a participant to be considered as a probability sample, she must be selected using a random selection. There should be no preconceived method of selecting the sample. It should be completely a random selection. The most important requirement of probability sampling is that everyone in your population has a known and an equal chance of getting selected. So if there are a total of 100, each element should have a probability of getting selected as 1 by 100. None of them should be having 5 out of 100. The others should be having maybe 1 out of 100. So each element of the population should have equal chance of getting selected. Right? Now, probability sampling also uses statistical theory to select randomly a small group of people from an existing large population and then predict that all the responses together will match the overall population. So this is where probability sampling is important, because if you're opting for probability sampling, you can use statistical theories, which you are studying throughout the sessions, and to select randomly a small group of people, the sample for your research, and then based on the analysis which you have done for your sample, you can predict that the same responses or the same results you will get for the overall population, right? Now, as we were discussing, these are the different types of probability sampling. That is simple random sampling, stratified random sampling, cluster sampling, and systematic sampling. Now let's move to each one of them separately, though they all are part of probability sampling. That is, in each element of the population will have equal chance of getting selected, but there are different methodologies which we use. So in this next we will discuss as to what is a typical type of technique of probability sampling, what are its advantages, disadvantages, when do we use it, all this, right? Now, simple random sampling. I'm sure most of you must be already knowing or must have studied it in your research methodologies. As the name suggests, it is completely random method of selecting the sample. There is no methodology, which helps you to decide as to how you will use it. It's completely random. This sampling method is as easy as assigning numbers to the individuals and then randomly choosing from those numbers through an automated process. The traditional ways of selecting sample using simple random sampling is the lottery method and the random table numbers. Right? So lottery method is as is written here. What we do is, when we know the whole of population, we simply give each population a number, each element of the population a number, and we put it in a box kind of a thing, and we take out the lotteries. And suppose I want 500 sample, so 500 chits I'll pick out, and those 500 chits will become my sample. That is one method. The other is using different kinds of random table numbers. If you do a Google, you'll get a lot of random table number options from which you can randomly select the 500 or 1000 or whatever random samples you want, right? So, when do we use simple random sampling? This is very important. Theoretically, we all study, okay, this is stratified, this is simple random, this is systematic. But as a researcher, we fail to understand when to use what, right? Which method is most suitable for my research work. So simple random sampling is generally useful or is applicable when the population is small, homogeneous, and readily available. Right? So when these three conditions are fulfilled, when it is possible for you to write down the whole of the population in the form of chits, in the form of giving them numbers, when there is no difference between the different elements, all these elements are, say, homogeneous, and when the whole of population is very easily readily available to you, that is when we use simple random sampling. All subsets of the sampling frame are given an equal probability. Each element of the frame does an equal probability of selection. So in a sampling frame, we give equal probability to each element, and hence each element, of course, has the equal probability of getting selected in the sample. It provides for greatest number of possible samples. This is done by assigning a number to each unit in the sampling frame. So when you're using simple random sampling, it also helps you in conditions when you want a very large size of sample. Whenever you have a large sample size, that is when we use simple random sample. But now see, there's a contradictory. Above I said when the population is small, we use simple random sampling, and now I'm saying when you need a big sample size. So simple random sampling is basically used when you have a small population, and out of that small population you want a big sample size. It helps you to get a big sample size at ease. So that is where we use simple random sampling. And simple random sampling, of course, can be done by a table of random numbers or lottery system, right? Now, what are the advantages? It is easy to calculate. Simple random sampling is always an EPS design, but not all EPS designs are simple random sample. If sampling frame is large, this method is impractical. Suppose, which is generally a practical situation when your population is big, right? That is when we find it difficult to use simple random sampling, right? And minority subgroups of interest in population may not be present in sample in sufficient number for study. What happens is, suppose in your sample, let me take an example of, say, 100 people. Now, out of those 100 people, 40 are doctors, right? 30 are engineers. So we have a 70 count. We have 20, CAs. We have 5 military people and another 5, say, professors, right? Now, what happens when you're using simple random sampling? These two domains, that is defense 5 people and professors 5 people, you might not get a good representation of these two subgroups, which are in a minority in your whole of population, in the sample. And therefore, your conclusions might not be as appropriate for the research work. Right? I hope I'm able to make it clear to you that what happens in simple random sampling, where is randomly picking up. So there is a chance that all these 5 professors are not even selected in the sample. Right? So their opinion could not be registered for the research work. And that is the major disadvantage of simple random sampling, because we do not consider the minority subgroups here. In random sampling, there are 2 methods by which we do, we select the sample. One is without replacement and the other is with replacement. Now, sampling scheme with replacement is when you select an element and then you send it back into the population bag and then you select it again. So one sample has more than one options of getting selected. Like an example which I've mentioned it here is that if you catch a fish, and then you measure it and then you throw it back into the water. Again, when you catch a fish, that same fish has a chance of getting selected, right? So this is where we have the difference of random sampling with replacement and without replacement. That is when one sample has more than one chance of getting selected in the sample. That is when we call it as simple random sampling without replacement and with replacement. Now we come to the second kind of probability sampling, that is stratified sampling. Now we were discussing a demerit of simple random sampling, that is it does not consider the minority subgroups. So a solution for that is to divide your large population into smaller groups. And then what happens is from these samples, we randomly select our sample. So the problem which we had is now solved, right? It involves a method where a larger population can be divided into smaller groups that usually don't overlap but represent the entire population together. Right? While sampling, these groups can be organized and then draw a sample from each group separately. A common method is to arrange or classify by their sex, by their age, by their ethnicity, and similar characteristics. So in stratified random sampling, what we do is the whole large population, like you can see here as an example in the image, you have some male, you have some female, and you have some kids. So if you use simple random sampling, what could have happened is that the kids might not have been gotten selected in the sample. So in that case, we use stratified sampling, in which we first divide them on the basis of their gender, their age, their ethnicity. It could be anything, income, any of the demographic factors which we have. And then from that, we then select our random sample. I hope I'm clear to you. Like, see, I have another example. I don't know why the slides are running through. See, yes.
Ma'am, I can't see the slides. For me, the screen is showing just the first slide of the presentation. I don't know it's happening with other participants.
Can any others tell me if it's happening for the others as well?
Yes, ma'am. For me also it's like
I am so sorry. I'm so sorry. You should have told me before.
Ma'am, I've written in the chat also, but maybe...
I was doing it on full screen, so that is why I didn't see the chat. Just a minute, I'll share
Sorry
it.
to disturb you. Sorry.
It's thank you. I would like to say thank you that this, at least you're raising a voice after at least 30 minutes, but thank you.
I thought maybe my screen is stuck, so I gave a message.
No,
in the chat.
no. Let me just let me know if it is now visible. Is the slides moving?
yeah, ma'am. Now it's visible.
Okay,
Yes.
so what I'll do is I'll use 2 minutes to just show you through the slides so that at least you get to know what we were doing.
Yeah, sure. Thank you.
And thank you so much for telling. Okay, so see, we were discussing sampling. Then we had this population and sample part where, each element is being mentioned. Then we discussed about the sample and why it is necessary. Then the population. This is how you have a population. You have a sampling frame, and then you have sample. So there's a big population, then you select your target selected sample from which the interest, you have the interest of your research, and then you finally select your sample, right? Then these are the characteristics which you have of a population, that is homogeneous, stratified, proportional stratified, grouped by type, and grouped by location. Then we moved on to the sampling methods. That is probability sampling method and the non-probability sampling method. Just let me know if I'm doing a slideshow and you're able to see it. Are the slides moving?
Yes, ma'am. Now we can see this.
Okay, thank you. Let me know if it hangs again. All right. So these are the different sampling methods, that is probability sampling and non-probability. We discussed as to what is probability sampling. There are 4 different methods of probability sampling. Simple random sampling, we were selecting randomly using lottery method or random table numbers. Then we discussed about the advantages, disadvantages. Then we moved to stratified and see how we are dividing them. This is where we were, right? We were here. So this is how you make a stratified random sampling. That is, you first divide your whole of population based on age, gender, demographic factors, like we have divided here based on gender. And then if you had to select a sample of size of say 6, we select 3 from female, that is the first strata, and the 3 male from the second strata. So you have equal representation of both the stratas. In stratified sampling, we call it as strata, the groups in which we divide them. All right. Now, the drawbacks of using stratified. Of course, each method will have its own drawbacks. The sampling frame of entire population has to be prepared separately for each stratum. That is, for each stratum, you need to make a sampling frame from which the random sampling will be done. Then second, when examining multiple criteria, stratifying variables may be related to some but not to others, further complicating the design. So, the criterias which you are making should be less complex, because many a times what happens is we make complicated criterias and, multiple criterias on the basis of which we are stratifying the population. And that leads to confusion, and we're not able to divide them into different strata. So maybe some strata will have those elements, the other strata will not, will have those elements. So you need to stick to some simple characteristic based on which you will be dividing them into different stratas. Finally, in some cases, such as designs with a larger number of strata or those with a specified minimum sample size per group, stratified sampling can potentially require a larger sample than would other methods. So what happens in stratified is you generally have to have a large population. Only then you will have a significant number in each strata, out of which then, the stratified sampling can then be done, right? So this is how stratified sampling is done. Next, we move to cluster random sampling.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, the slides are again stuck.
Ma'am, again, ma'am, at
Let
9,
me
ma'am.
do one thing. I will not do a slideshow. I'll just do it without the slideshow part. I hope this will be better. Is it moving now?
Yes, ma'am.
Okay. So we will not do a slideshow. We will do it like this. So the next sampling method is cluster random sampling. Now, in cluster as well as in stratified, I think someone has his mic on. Can you just? It was echoing. All right. So what happens is we have cluster random sampling, and in between stratified and cluster, the major difference is that in cluster we divided based on some geographical diversions, some geographical bifurcations among the different groups. So in stratified sampling, we were doing it based on demographic factors, like age, gender, income, all this. And in cluster random sampling, we do it on the basis of geographically how spread these participants are. For example, based on cities, based on countries, based on talukas, villages, cities, all these things could be your way of dividing your population into different cluster. And from then those clusters, we randomly select our sample. So, for example, we can do that. Suppose you want to do a research on different villages of India, on the rural part of India. So what you do is you divide the whole of the country into, say, different states, which we have. And then from each state, you take 5 villages, one from the north side, one east, one south, one west, and one center. So this is a way of doing a cluster random sampling, whereas first you divide your whole of population based on geographical layout, and then from that you randomly select your sample. So this will form a part of your cluster random sampling. I hope I'm clear with this. Any doubt? I know this is a theoretical part, so a lot of doubt might not be there. And you all must have already studied all these parts. So next is, what are the advantages? It cuts down on the cost of preparing a sampling frame. This can reduce travel and other administrative cost. You are easily able to plan your whole, traveling of collecting data. And it has sampling error is high for a simple random sample of samples of same size. So compared to a simple random sample of same size, the sampling error which you'll get with cluster sampling would be higher. So these are the different advantages and disadvantages. Here I've tried to show the difference between stratified and cluster, because generally what happens is the research scholars get confused between these two. So population is divided into few subgroups. And then in stratified, what happens is we divide the population into few subgroups. In cluster, we divide the population into many subgroups, as many as possible. And then each subgroup has many elements. Now understand the difference. What happens is in stratified, we first divide the population into few subgroups. And then from each subgroup, we select more elements, right? And in cluster, what happens is we first divide the population into many subgroups. And then from each subgroup, we select few elements. Now in stratified, subgroups are selected according to some criteria that is related to the variables under study. And in subgroups or in clusters, subgroups are selected according to some criteria of ease or availability of data. Like suppose I have to do a research on rural parts of India. What I'll do is I'll choose the villages which are nearby, which are of ease to me. Like say I can go up to Maharashtra, Madhya Pradesh, and do a research and come back. Right? So it is totally on us, and we can divide it geographically and then choose any cluster I want. If out of say there are 28 states, I'll only select in my cluster 10 states which are nearing to my state. Right? So this is how cluster sampling is done. In stratified, this is again a very important difference between the two. In stratified, understand it clearly, there is homogeneity within subgroup. That is, one group or one strata will have elements having a same characteristic, right? And all these different groups will be heterogeneous to each other. So group 1 may have all females and group 2 will have all males. So within the female group, there is homogeneity and there is heterogeneity between the subgroups, right? And then you choose from that your elements. In cluster, there is heterogeneity within subgroups. Now, suppose there is village A with all male, female kids, everyone. There is village B with male, female kids, everyone. Now, when there is heterogeneity between subgroups, that is, within that group, the elements are different from each other. But when you compare the two groups, you will find there is homogeneity. That is, group 1 is also a village, group 2 is also a village. The annual income of all the people living there is below poverty line, for example. And group 2 also has a similar thing. So that is the difference between stratified and cluster sampling. Now, after discussing about simple random sampling, stratified sampling, cluster sampling, the fourth probability sampling, which we are about to discuss, is systematic sampling. Now, what is systematic sampling? It is a very convenient way of doing, but uses the same old probability technique in which each member of the group is selected at regular periods to form a sample. So suppose you have 1,000 people with you, and you have to select, say, a sample of 100 people. So what you exactly do is, you divide the whole of the population, that is 1,000, divided by the sample size, which is 100. So you get your nth value as 10. So what I did, how did I get this 10? The whole of the population divided by sample size gives you the nth value. Now what we do is, from your population, you meet every 10 person, or you tick every 10%, and that becomes a part of your sample. So this is known as a systematic sampling. Like, for example, if you see below, the nth value here is 3. So what happens? First, the third element is selected, then the sixth element is selected, and then the ninth element is selected, and so on, 12, 15, and 18, and so on. So this is systematic sampling, in which each element has equal chance of getting selected, and we use the nth method of selecting a sample, that is dividing the whole of population by the sample size, giving you the value of n, and then every nth value is part of your sample. I hope it's clear. Now, the advantage of systematic sampling are its sample is easy to select, suitable sampling frame can be identified easily, sample evenly spread over entire reference population. Of course, you are going through the complete population, the whole set. You will start from number 1 and you will end at, say, there are 1,000. So you will continue till 1,000th population. So you are taking samples from the entire population. The major disadvantage is sample may be biased if hidden periodicity in population coincides with that of selection. Now, what happens? We researchers are very smart. We want to get the results which we want, and we could do many kind of manipulations. One such manipulation is, now suppose I, being a professor of Amity, now I am doing a survey on IQ of students, right? Now, for other schools or colleges, what I'll do is I'll select randomly, being very unbiased, and select all my sample in a very honest way. For my own university, what I'll do is I'll do a systematic sampling, and purposely I'll keep that in the most intelligent students at the nth positions. So what happens? Automatically, when you'll do the result, you will get a better result, right? So many a times there could be hidden periodicity or hidden biasness, which a researcher can possibly do in systematic sampling. And there is difficult to assess precision of estimate from one survey. So generally, when you are using systematic sampling, you have to select 2 or 3 samples from your population, and then draw conclusions and check for the results which you're getting from the multiple samples which you have selected, right? Now, after we have discussed probability sampling and the 4 types of probability sampling, that is simple random sampling, cluster sampling, stratified sampling, and systematic sampling, the next type of sampling includes the non-probability techniques, which we were discussing as those methods, which does not have this concept of equal chance to each element. This is the simple difference. In probability sampling, you give equal chance to each element to get selected, while in non-probability sampling, you do not give equal chance to each technique to be selected. This is more of as per the researcher, their convenience, their judgment, and so on. So basically, we have convenience sampling, we have judgmental sampling, we have snowball, which is now being commonly used and a term which most of us now know, and quota sampling. Right? So now what happens in convenience sampling? It is a non-probability sampling technique which is used to create sample as per the ease of access, readiness to be a part of sample, availability at a given time slot, or any other practical specification of a particular element. Convenience sampling involves selecting haphazardly those cases that are easiest to obtain for your sample, such as the person interviewed at random in a shopping center for a television program. Now, what happens in convenience sampling? Like I'll always give my own example. Now, suppose I have to do a research on youth of Jharkhand, right? I need a sample of, say, 1,000 students. The most convenient way for me, what would it be? It would be to get my own students and do a survey on them. So what happens in convenience sampling? Convenience word itself means with your ease, with your, without going into any kind of trouble if you're able to get your sample. So elements, there are other different things. First, as a researcher, you should have easy access to that sample element. Second, that element should be ready to be a part of your sample. Right? Then he or she should be available at that given time, and any other thing. So basically, suppose you as a student are doing a research work on, say, you belong to banking industry and you're doing your PhD thesis on, say, banks and financial instruments. So what you'll do, you'll simply, if you have to do it between two banks, you will automatically take your own bank as one bank. And you will select all your friends, all your contacts into the sample. Rather than visiting the different branches across the country, you will prefer doing it with your own bank employees. Because, of course, they're also a part of that bank X. There's nothing wrong with your doing. So this is known as your convenience sampling. Next is judgmental sampling. Now, what happens in judgmental sampling? In judgmental sampling, which is also called as purposive sampling, the sample members are chosen only on the basis of the researcher's own knowledge and judgment. It enables you to select cases that will best enable you to answer your research questions and to meet your objectives. Now, as I was saying, non-probability sampling is always on the judgment of the researcher. So what happens is judgment sampling is, I want, say, result X. Now, I know that if I select these 50 people into my research study, I will get the answer which I want for my research. Correct? Now, what happens is, suppose you are working in an automobile showroom, right? And your manager tells you to do a research on customer satisfaction, right? You are sitting there and you're watching. And people who are leaving the showroom with a smile, who are very happy, who have maybe bought a car, you will only do surveys on them because you want the result to be best so that you can send it to the automobile company that my customers are best satisfied. There is no need, no negative feedback. So what you'll do, you'll only take feedbacks from the happy customer. You will not take feedbacks from the people who are fighting at the counter. Right, so that is judgmental sampling, where you know what you want, you know what you desire as your result of the research, and on the basis of that, you then select your sample members. Now, next is the snowball sampling, which is now very common and very convenient for everyone to do. This chain will help you to understand what exactly is snowball sampling. Now, snowball sampling is purely based on referrals. This is also called as a chain referral sampling method. This sampling method can go on and on just like a snowball increasing in size till the time a researcher has enough data to analyze to draw conclusions that can help an organization make informed decisions. Have you ever seen a small peck of snow falling down from the tip of a mountain? What happens? The ice keeps on getting accumulated and the ball starts becoming big, and as big as it could devastate the whole of the place by falling on the ground. So similarly, with a similar concept, the snowball sampling is where you as a researcher meet two people, right? And then you take data from them. Now, you ask those two people to refer maybe 3 more people to you, right? So element 1 has given you name and contacts of 3 elements. And element 2 has given you name and contacts of 3 elements. So now you'll move to those 3 elements, and from each of these element 3, 4, 5, and 6, 7, 8, you'll again ask to refer names of 3 people. So this is how you keep on growing your sample size until and unless you are happy enough, you are satisfied enough that you have now enough data to work upon your analysis part. So this is an indefinite part, and you can continue doing it till you get the maximum sample size as much as you want. So this is about your snowball sampling. The last non-probability sampling is quota sampling. Now, what happens in quota sampling is, suppose we fix quota that there is some pre-standards, some specific attributes which is necessary when you select a sample. Like say, there are 20 people, and you are given that out of those 20, when you are selecting your sample, 10 should be above 50, 5 should be above 30 and below 50, and 5 should be between 20 to 30. So this is a preconceived thing as a standard which is given to you before you do your sample, right? So in that case, those male above 50 or those people above 50 has the chances of getting selected, that is 10 out of 30 if there are sample size of 30. Now this is most common when we are having examinations and there is some reservations for different people of different income, maybe people belonging to different castes, belonging to females. You will see many places, government banks or government places, there's reservation for females. So say if there are 150 seats which are vacant, for which the competition is being held, 40 seats are reserved for female. Now, if there are 150 seats and 40 are reserved for female, if suppose there are 1 lakh male who have applied and there are 40 females who have applied, so in that, because of that quota, all those 40 females will be selected, because it is a preconceived thing that 40 females have to be selected, right? So this is about your quota sampling. So when we talk of sampling, what is sampling? What is the need of sampling? What are the different types of sampling? I hope is this clear to everyone. Before we move to data processing, is this okay, or would you like to discuss something? One thing which, I don't know if you'll ask me or not, but one thing I would like to tell you, or first I would like to ask, how do you decide what sample size to take? I have to take, 500 samples. How do you decide this? The sample size should be 500. Anyone would like to tell me, how do you decide your sample size? Or is it just your guide or your professor who tells you ki you need to take 300 sample size and you'll get a good result? Is this how you decide your sample size?
Ma'am?
Yes?
Ma'am, from some articles I have read,
yes.
It was written that 300 sample size is the standard.
Yes, that is what I said. That we generally, take it that 300 sample or 350 sample size is good enough. But statistically, there is a formula which helps you to decide your sample size. If you wish, you can do it through calculators, with that formula. Or if you just Google a sample size calculator, if you have your mobiles with you right now, I would request you all to put in your on your Google sample size calculator. This is something which many of your people might not guide you, that you need to actually decide the sample size before you go for your sampling data analysis. Now, if you see this, you have a confidence level, you have a margin of error, you have a population proportion, and you have a population size. And it very clearly tells you that you can choose a confidence level as per your research. That is, it has the option of 70%, 75%, 90, 95, 98. So basically in social sciences management, we use 95, 98 or 99. So you can choose the confidence level as per the research you have done or you're trying to do. The margin of error, whatever you're taking, like if you're taking it as 95, your margin of error will be 5. If you're taking it as 98, it will be 2, and so on. Population proportion, if you're not sure, you can put it as 50%. And population size, if you know Like suppose I know that I have a population size of 1000. So you can put it as 1000, or if you are not known, you can leave it blank. And then if you put the calculate button, you will get your sample size as to what should be the sample size. Now, suppose I have taken my confidence level as 95%, margin of error as 5%. Would you like me to do it on the screen, or are you able to see in your own Googles? Should I share my Chrome and show it to you? Or are you able to see it on the Google?
We can do it on Google, ma'am.
Good. So if you do, you will see if I'm taking the population size as 1000, I'm getting the sample size as 278. Now this 278 is the sample size, but we need to keep a margin and maybe take my sample size as 300 or 320. Why? Because many of our respondents might not be giving us the responses, or might not be willing to fill the complete questionnaire or the complete schedule which you have sent it to them, right? And if this is the easiest way of doing a sample size calculation. Otherwise, you have a formula for sample size, that is Z score square. That is, you must be knowing at 95% the Z value is 1.96. At 99% it is 2.58, and so on. So whatever confidence level you have taken, you need to take the Z score for that. That is Z score square into the standard deviation. If you are not able to calculate the standard deviation, we ideally take it as 0.5. And if you are able to calculate it well and good, you'll put your standard deviation there into 1 minus standard deviation. So what happens is your numerator is Z square into standard deviation into 1 minus standard deviation, right? And this whole numerator divided by the denominator will be confidence interval square. So whatever confidence interval you have, that square will give you your sample size. That is, if you are using, for example, 95% confidence level, and if I don't know the standard deviation, I'll take it as 0.5. So my sample size formula will be 1.96 square into 0.5, again into 0.5, because you have to do it a 1 minus, divided by confidence interval here is 95%, that is 5% will be your margin of error. So 0.05 square, that will be your denominator. So you will get your sample size from this. I hope this will be helpful for you all. Rather than taking it randomly at 300 or 400 or 450, there could be a question when you are presenting it to your evaluators as to how did you decide your sample size. And if you give an answer there that my guide told me to take it as 300, that will be a very negative thing, right? So I would recommend you to please use this sample size calculator to mention it in your thesis as to why you have taken it as this particular sample size. I hope it's clear. Okay, we'll move to the next part and a small part, which is data processing, before we take a lunch break. Kalyan Sardar, if you can mute yourself, there's some sound from your end. The host can put him on mute, I don't know. Yeah, thank you. So now the next part again, once you have decided your sample, you have designed your questionnaire, you have collected your data. Before analysis, one of the most important part is data processing. You have received, like, say, 500 questionnaires. Now, what do we do with that? How do we make it ready to be fed into SPSS or to any other software, or do it manually, whatever? So this is the next important part, that is data processing. Now, under data processing, I hope the slides are moving. Let me know if it is not. So we will be discussing as to what is data processing, then analysis of data, interpretation, and the problems we face in processing of data. Data processing. That, as we were saying, the data after collection have to be processed. You need to polish your data before you actually feed it into your analysis part. So this is where you process, and then you lay out the purpose at time of developing research plan, whatever initial planning you had regarding what you want from that data. This is where you tabulate, you edit, you code your data, you classify your data so that the initial plan which you had developed is fulfilled. That is your research design, your research objectives, your research questions, your hypothesis. You have genuine data to analyze for all these things. So, processing of data basically involves 4 things. That is editing the data, coding your elements. The first step involves editing that data. It is very important. I'm saying it again and again. Before you jump into the analysis, okay, I know analysis, I've learned SPSS, I've learned the various softwares and I can do it. You need to use data processing method, right? And in this, the first is editing the data. It is careful scrutiny of data to ensure that the data are accurate and eliminate errors as far as possible. Following are the points taken into account for editing the data. You need to first reject incomplete set of data which you have received from the elements. If there is any questionnaire or anything which is incomplete, any interviews conduct which is incomplete, you will reject those elements from your sample. That is why I said to take 15, 20, 30 extra sample size. You need to then check for accuracy. That is, the responses which you have received, is it actually what you wanted for those questions? Now, suppose I am saying put A for apple and B for ball. Now, the respondent, what he did is he wrote Y and Z. Now, you're not sure that Y represents apple or that Z represents ball. So you need to check for the accuracy and the uniformity of all your data, that everything is very uniform. The whole data which you have collected is complete, accurate, and uniform. So before you move forward, the first step includes editing the data which you have collected. The second part includes coding of data. Now again, people, when you are taking data from them, you cannot ask them, or many a times we do, but still, to make it easy for the respondents, we write those questions in words, right? Like, for example, mention the annual income, right? And you have put it below 1 lakh, 1 lakh to 5 lakh, 5 lakh to 10 lakh, 10 lakh to 20 lakh. Now, but when you're putting it in your software, you cannot put this as below 1 lakh, 1 lakh to 5 lakh, 5 lakh to 10 lakh, and so on. So in that case, what we need to do is we need to give codes to our responses. Like, for example, see, if you had a question about the educational qualification of your respondents. Now, when you were giving the questionnaire to your respondent, you used the left column. That is, you mentioned it in your questionnaire, illiterate, able to read and write, up to primary, up to that should be secondary, college and above. Right? And when you have taken it from the respondents, what you have to do is, we generally do it on an Excel sheet. We give codes to each. So now I have 500 questionnaires. I pick up the first, and this is question, say, 2. So for question 2, what I'll do is, for question 2, respondent 1, my code will be, say, 2. That is, he is able to read. He has ticked on able to read. Now, for that same question, I'll make a whole, say, column, and each respondent will be one, like, there could be different columns. The first row represents question 2, and then each column will represent one element. So I'll keep on doing 2, 3, 4, 1, 2, 3, 4, depending upon the responses which each respondent has given on that question. Now, this has to be done for all the questions. That is, you need to change the responses of your respondent from words to numbers, because statistics can only understand numbers. It cannot understand words. So you need to change it completely into numbers, right? So this is the coding part. Next is, after editing and coding is over, the process of classifying or grouping of data starts. That is, you classify your data into quantitative and qualitative. I'm sure it is clear as to what is quantitative and what is qualitative. For example, there are some questions wherein you have taken responses in numbers, and there are some questions where you have taken it in words. So you need to divide your data as to which all questions or which all parts represent the quantitative part and which all part represents the qualitative part, right? So that is classifying of data. You classify them into two parts, which all can be analyzed quantitatively and for which all you will need qualitative methodology, right? Then the last important part of data processing is tabulation. That is, as it said, tabulation is the orderly and systematic presentation of numerical data in a form of design to elucidate the problem under consideration. That, as I was saying, we do it in the form of an Excel sheet. You tabulate your data and you make a complete Excel sheet with all the codes, proper edited, proper classified and everything. It is concise, logical and orderly arrangement of data in columns and rows. What is the objective of tabulation? You conserve spaces and minimize explanation and descriptive statements. That is, after the theoretical part, we are now moving, we are removing the statements, we are removing the words, and we are converting everything into numbers. You facilitate the process of comparison and summarization by making tables, by coding, by classifying. You're helping the whole process of comparing and summarizing. It also helps in detecting errors if there are any, or if there is anything which has been omitted. Establish the basis of various statistical computation. This is where next step involves data analysis. So data processing helps you to get the data ready, edited, properly tabulated for your analysis part. Now, these are some basic principles which you need. That is, table clear, concise, and adequately titled. You know, the rows and the columns should be properly titled as to what is that data representing, because 6 months or 1 year to your data set, you will get confused as to what is that all about. So every table should be distinctly numbered for easy reference. Column headings and row headings of the table should be clear and brief. Units of measurement should be specified at appropriate places. Now, suppose you are writing something in pounds, it should be written in the row heading that these elements are, numbers representing weight in pounds. Because generally, we Indians, what we'll do, if there's a weight written above and there is 50, we'll consider that as 50 kg. So the unit of measurement is also an important part. Explanatory footnotes concerning the table should be placed at appropriate places. Sources of information of data should be clearly indicated, right? So all these things are very important when you are tabulating your data. So this is all about your data processing. And we are back. Let me know if you have any doubts for this session, that is sampling and data processing, before we take the much awaited lunch break. Okay, so I consider that we have no doubts. Satyajit sir, if you're there, can we quickly take a lunch break and meet again at 2 for hypothesis testing and development? Okay. So the participants, thank you so much for being so, patient listeners. I'm so happy to have you all here. And let's take a quick lunch break and we meet again at 2 p.m. I'll leave the group now and rejoin again at 2. All right. Thank you so much, everyone.
Thank you, ma'am.
Thank you, ma'am.